In this video, we're going to look at some introductory area examples and how they relate to rectangles. And we're going to do this by looking at applied examples. So in this first example, we've got a company called Sector 9 that produces long boards. So it costs them $40 per board to produce the first 50 boards. Then after 50, it costs them $30 per board to produce the next 75 boards, and $25 per board to produce the next 100 boards. So what we're going to do is find the total cost to produce a total of 225 boards. Okay, and we're going to do this graphically as well. So let's put a little graph here. This is going to be number of boards on the x-axis and price per board on the y-axis. Price per board there. Okay, now the price starts at $40 per board, and then the more boards that are produced, the cheaper it gets to produce them. So it decreases to 35 and then 25. So let's go by 5s, 10, 15, 20, 25, 30, 35, 40, okay? And this is in dollars per board. All right, now, cost them, let's see, we're going all the way up to 225 boards, so let's go by 25s. So 25, 50, 75, 100. Let's mark 50. And then, so it costs them a certain price to produce the first 50 and then a different price to produce the next 75, which would put us out here at a total of 125. And then the next 100 cost a different amount. So 1, 2, 3, 4, there's 225 there. Okay, now it cost them $40 per board to produce the first 50 boards. So the price per board is $40 for the first 50. Okay. Next, it cost them $30 per board to produce the next 75 boards. Okay, so the price drops to $30 for the 51st board through the 125th board. And then the price goes to $25 per board for the next 100. So it drops down like so. Now, we want to find the total cost to produce 225 boards. So we're going to do this by finding the total cost to produce the first 50, the total cost to produce the next 75, and the total cost to produce the next 100, and then we'll add those three total costs together. Okay, so total cost to produce the first 50 boards is the number of boards times the price per board. So the number of boards is 50 times the price per board is 40. So it's going to be 50. I'm going to include units just on this one. 50 boards times $40 per board. Just because I wanted to show you the boards units cancels and you're left with dollars. So 50 times 40 is $2,000. Okay, then the cost to produce the next 75 boards, that's this 51st board through the 125th board. There's 75 boards total at a cost of 30 each, so it would be, well, let's be consistent here, so 75 boards times $30 per board. Okay, 75 times 30, I'm going to pull out the calculator for that one here. So 75 times 30 is $2,250. And then the total cost to produce the next 100 boards, if you can read that, is 100 boards, that's the number of boards being produced, times their price per board is only $25 per board. So 100 times 25 is $2,500. Okay, so total cost to produce the first 225 boards is the sum of that, and that. So we're going to do $22.50 plus $2,000 plus $2,500 to get $6,750. Okay, now the important thing here that we want to take away is this idea that the total cost really corresponds to the area under the graph of the price per board, which is marginal cost. Price per board is the same as a marginal cost function. Okay, so the 50 times 40, yeah, this is $2,000. That also corresponds to the area of this little rectangle here, 2,000. Right, then this width 75 times the height 30 corresponds to the area of the middle rectangle, which is 2,250. And then 100 for that length times the height of 25 corresponds to 2,500. So the area, the sum of the areas of these rectangles, or the area under this marginal cost function, equals the total cost to produce a certain number of boards. Okay, next let's look at a different application which involves velocity and displacement. So this is something that you can relate to as being a person who has ridden in a car, or even better yet, hopefully you have driven a car. Okay, so suppose a car travels at a constant 60 miles an hour for 2 hours. What is the displacement of the car over that time? Meaning, how far did it travel? So if your speed is 60 miles per hour, and you travel for a total of 2 hours, you've gone 60 miles in each of those 2 hours. So you've traveled 120 miles. Okay? So if you graph the velocity function, or the speed right here, the speed is 60. Okay, and we can draw in a little line here for the time. Okay, look at the units here. This is miles per hour on the y-axis, and this is hours on the t-axis. The 60, or the height of 60 times the width of 2, corresponds to the area of that rectangle, or the area under the velocity curve. Of course, most objects don't move at a constant velocity, so what we're building towards is extending these ideas to apply them to problems where the velocity does change over time, or perhaps to apply them to a marginal cost function where the marginal cost is changing with every single item that is produced.